Welcome to this series of presentations on LXI. This presentation will focus on various applications of test systems that use LXI devices. There are core features that all LXI devices have in common, and those enhance building a test system. But there are also unique extended functions available in LXI that can address some really tough measurement applications. Key points of this presentation were taken from the LXI Consortium document, Test Systems Using LXI. That document can be found on the LXI Consortium website and provides more detailed information about various LXI devices and how they can address almost any type of measurement application. The last slide of this presentation gives you a specific URL to locate this and other LXI documents. LAN connectivity is common. Fast, inexpensive, reliable, all those features you want in a test system. However, adding LAN to an instrument does not mean all devices will work the same when connecting to the LAN. LXI, which stands for LAN Extensions for Instrumentation, is the standard for Ethernet control of instrumentation in the test and measurement industry. Prior to this standard, there were LAN-based instruments, but there were almost as many different ways of configuring those devices as there were products. With the LXI standard, all devices behave the same when connecting to LAN. They all come with easy-to-use IVI drivers, example programming, and most have added web pages for monitoring and controlling functionality. And there are more than 3,600 products in over 50 different product families. LXI is particularly favored by the aerospace defense industry, where strict adherence to standards and compliance is a necessity. By standardizing and extending the LAN to instrumentation support, LXI simplifies the use of Ethernet for test systems, providing a low-cost, cross-platform computer interface that can be controlled at virtually any distance. For a test system engineer, it is usually inconvenient and uncomfortable to work next to that test system. He wants the comfort of a quiet office environment to develop his test programs. And he might even be supporting test systems that are not even in his facility. The test systems covered in this presentation will all benefit the test system engineer by providing built-in web servers. This enhances productivity, since the test developer can see what is happening as the test program is implemented. And if something stops working properly, visibility into switching and instrument configuration can quickly identify issues. Here are the test systems covered in this presentation. Just from these images, you can determine that LXI covers not only proprietary implementations for signal generation, signal measurement, and switching, but you will note the presence of VXI and PXI modules through the use of LXI bridges. This test system has a wide variety of instrumentation used to test various PXIe modules. The PXIe modules operate from DC to multi-gigahertz and must have each of their key specifications verified during production. This requires precision switching and precision instrumentation from DC all the way up to multi-gigahertz. Accuracy of the module requires the measurement or stimulus instruments have greater accuracy. This often dictates standalone products with lots of space for isolation of signals and their own power generation. This particular system also has electronic loads for testing module power supplies, which requires significant power dissipation and dictates a standalone solution. The combination of measurement needs has resulted in a hybrid system where there is one USB and two GPIB devices, with the rest all LXI. The test system utilizes an embedded computer in the PXIe mainframe, which controls all the instrumentation in addition to controlling the PXIe modules using IVI drivers and sometimes direct control using the Skippy language. Each LXI device connects to a multi-port LAN switch, which then connects to one of two LAN ports on the embedded computer. The other LAN port connects to the corporate or company LAN, giving remote access to the test system developers. This configuration was specifically chosen since there are three such systems located in geographically different locations, thousands of kilometers apart, and regular updates to tests and issue resolution can be performed remotely. With a test system full of various signal generation, measurement, and switching products, you need a way to see what's going on, especially if you're troubleshooting remotely. It is a common solution to remote log into your test system, nothing special about that. But with LXI devices, that remote connection then provides web page access to the various measurement and control devices. For example, a test is failing, so you step through the test program looking at the result on a scope web page. That doesn't look right, so you check the switch path using the switch web page. Wrong combination of switches. Problem solved, and it was all identified remotely. Wind tunnel facilities provide the equipment and expertise to develop and conduct tests used to characterize the aerodynamic and propulsion parameters of aircraft and vehicles. The heart of the wind tunnel is used to perform a variety of tests, including force tests, pressure tests, and airflow pattern measurements. These types of tests require large data collection and high speeds to capture performance data. To reduce measurement signal connection lengths and those types of issues, the measurement devices are often installed as close as possible to the device under test, but far away from the control room. Using dedicated subnets for an LXI-based data acquisition system that guarantees the availability of wind tunnel facilities provide the equipment and expertise to develop and conduct tests used to characterize the aerodynamic and propulsion parameters of aircraft and vehicles. The heart of the wind tunnel is used to perform a variety of tests, including force tests, pressure tests, and airflow pattern measurements. These types of tests require large data collection and high speeds to capture performance data. To reduce measurement signal connection lengths and those types of issues, the measurement devices are often installed as close as possible to the device under test, but far away from the control room. Using dedicated subnets for LXI-based data acquisition applications guarantees the availability of network bandwidth for continuous data streaming and easy scalability. Configuration is accomplished via built-in standardized web interfaces on each of the LXI devices. This remote capability is suitable for wind tunnel, where test engineers can access acquired data from virtually any location. In this long-distance application, it is possible to measure group delay on a transmission system by means of two LXI-based network analyzers, one at the transmitting end and the other at the receiving end. They communicate with one another using LAN messages up to 100 to 200 meters apart. The LXI network analyzers are connected to one another via a LAN router with an integrated DHCP server that assigns IP addresses to devices. Or you could just assign fixed IP addresses to those devices. Another long-distance application is satellite testing. Satellites are involved in a wide range of applications, including scientific research, weather prediction, navigation, and military aerospace. The greatest numbers of satellites that orbit the Earth today are used for communications, enabling people across the globe to communicate with one another. In fact, more than half the satellites in space are used for telecommunications. Beyond telecommunications, satellite communications are intrinsically tied to almost every aspect of our daily lives, whether we realize it or not. The LXI clock synchronization extended function inherits IEEE 1588 2008 version of Precision Time Protocol, used to synchronize real-time clocks with sub-microsecond accuracy in devices of network distributed system. This allows common timer events to be tied to absolute times for very precise triggering and synchronization, and enables the correlation between instruments to aid monitoring and debugging. Companies such as VTI Instruments and Pickering Interfaces provide LXI bridges that enable the reuse of expensive modules to be deployed to new test systems. The LXI chassis has an embedded controller that requires access to the source code for the various modules that are supported, which are often restricted to the particular company's modules. The same controller gives the user a barrier between those modules and the test system computer that provides all the features of Ethernet connectivity, including web-based management of each of the modules. In this case, the LXI bridge device permits cycling power of the chassis without having to cycle power of the test system controller. The LXI chassis now becomes just another component in a hybrid system that can contain USB, GPIB, LXI devices, similar to the first test system example we talked about. So you've learned a lot about using LXI devices to create various test systems. You can learn much more detail accessing some of the same named documents on the LXI Consortium website. See this particular URL for access. Thank you very much for your time.